Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook! This one careless move cost a student an entire method mark on last year's paper. They cancelled the 2 from x plus 2 with the 2 in x minus 2 and finished the paper thinking they'd done the right thing. It looks tempting on the page, but cancelling across addition or subtraction is not valid. If you've ever felt a small trick like that sneak past you in an exam, stay with me. This episode will make those traps obvious and easy to avoid.
The concept, step by step. Let's start with something simple. Simplify x squared minus 4 over x plus 2. First observation, x squared minus 4 is a difference of squares. That means x squared minus 4 equals x minus 2 times x plus 2. So rewrite the fraction as x minus 2 times x plus 2 over x plus 2. Now you can cancel the common factor x plus 2 because it multiplies the whole numerator and the whole denominator. The result is x minus 2. Here's the why. Cancellation is allowed only when the same algebraic factor multiplies the whole numerator and the whole denominator. You're cancelling factors, not parts of sums.
Important point. Restricted values. Before you celebrate, note that x equals minus 2 is not allowed in the original expression because it would make the denominator 0. So the simplified form x minus 2 is algebraically equivalent for all permitted x, but the original fraction is undefined at x equals minus 2. In exam answers, always show that restriction. State x not equal to minus 2. That protects you from losing accuracy marks. Now a counter-example, why you can't cancel across addition. Take x plus 2 over x plus 3. Some students look and think, cancel the 2 with the 3. That's wrong. There is no common factor that multiplies the whole numerator and whole denominator. The numerator is a sum, the denominator is a different sum. You cannot remove digits or terms inside different sums. If you want to simplify, you must factorise fully first, and if no common factor appears, the fraction stays as it is. Next, solving an equation with fractions. Suppose you have 2x over x minus 1 equals 4. The safe route, clear denominators immediately by multiplying both sides by x minus 1. But before you do that, write down restricted values, x not equal to 1. Multiplying through gives 2x equals 4 times x minus 1. Expand the right-hand side to get 2x equals 4x minus 4. Rearrange to minus 2x equals minus 4, so x equals 2. Finally, check x equals 2 is not a restricted value and substitute back quickly to confirm the original equation holds. That substitution check is a tiny habit that catches sign slips. Why each algebraic move is valid. Factorising reveals multiplicative structure. Cancellation removes identical factors. Clearing denominators produces a standard polynomial equation, which you can solve by normal rearrangement. If you skip the factor step and try to see cancellations inside sums, you are relying on pattern spotting, and that's where marks disappear. The exam technique, how the marks are awarded. For a 3-mark fraction question, the typical split is M1 for setting up a correct manipulation or equation, M1 for applying an appropriate method such as clearing denominators or factorising and cancelling correctly, and A1 for the final correct answer with any necessary exclusions stated. For a 4-mark question, you might see an extra M1 for a correct intermediate step or expansion. That means the examiner expects to see your method written down. Don't just write a final answer without steps. Practical marking tips. Label steps roughly. For example, write factorise, then show the factorisation, then write cancel common factor, then show cancellation. If you multiply both sides by a denominator, write that line clearly, like multiply both sides by x minus 1. Even if you make an arithmetic slip afterwards, showing the correct operation often earns the M1. And always state restricted values explicitly.
Some examiners give an A0 if you give a correct algebraic answer, but forget to note x not equals something. The quick win, a 5-second checklist you can use right now. 1. Factorise first. 2. Write a single common denominator line when adding or subtracting fractions. 3. Never cancel across a plus or minus sign. 4. After solving, do the 10-second exclusion check. List values that would make any denominator 0 and make sure your final answer isn't one of them. If it is, reject it. Do these 4 things every time and you'll stop losing the obvious marks. A tiny extra quick win for speed. When you clear denominators, multiply through by the least common denominator in one neat line. That keeps you working tidy and the examiner can follow your logic easily. Read the question twice, solve it once. News recap. What exam boards actually say. Examiners consistently advise, show algebraic working, make factorization and cancellation explicit, and state any excluded values. Mark schemes award method marks for correct method steps, even if the final arithmetic is off. So practice writing those steps clearly. Examiners don't assume them, they award them when they see them. Practice prompt. Try this 3 to 4 mark question now. Solve 2x over x plus 1 minus 1 equals 3 over x plus 1. First, write down the restricted value, then clear denominators and find x. I'll give you 2 minutes to try it yourself. Ready? Your first line should be x equals minus 1. Then multiply every term by x plus 1. I'll pause. Try it out. Back now. If you multiplied through correctly, you'll have 2x minus x plus 1 equals 3. Expand the brackets. 2x minus x minus 1 equals 3. That simplifies to x minus 1 equals 3, so x equals 4. Check x equals 4 is not excluded, and substitute back if you like. 2 times 4 divided by 5 minus 1 is 8/5 minus 1 is 3/5, and the right-hand side is 3 divided by 5 is 3/5, so it checks out. Mark breakdown, M1 for writing x not equal to minus 1 and multiplying through, M1 for correctly simplifying to x minus 1 equals 3, A1 for x equals 4, and the quick check gives confidence. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.